In this block, let's continue to talk about data management, now focusing on DMPs, the data management plans. So, the DMPs are a way to reflect and organize a researcher's approach to all the activities associated with different stages of a data management flow. And what is that flow? Well, you can see it here. You plan, you collect, you process, you analyze, you preserve, you share, and then you reuse the data. With the openness approach, the most relevant element in the flow is sharing. Before, you could preserve your data for your own use in your own local servers or hard drives, and then you and your collaborators could reuse them eventually. However, with sharing, instead of being within your institution, restricted to a limited group of colleagues that could have access, the data are expected to be open to anyone interested. Of course, as a consequence, all the activities to manage data responsibly are now a little bit more complex. So we have the organization of the data, we have the documentation that was discussed in the video introducing FAIR data principles. We have storage and protection, we have sharing, and also the archiving of the data. With all that in mind, let's come back to the four elements of FAIR data that we discussed before, but now let's see some of the considerations that could apply to each of them in data management plans. So first of all, findable. When you're thinking about making data FAIR, you need to consider what persistent identifiers you use, which repositories to choose, and how you will deal with the metadata. That means, for example, defining the metadata model to be adopted, and we have mentioned the Dublin Core as one of the main alternatives available. You also need to think, for example, which metadata will be included and so on. When you're talking about accessible, you think about security, you think about access conditions, and you think about sustainability. Interoperable, you have to choose the software you use to process things. You have to think about the data formats that you're going to output and what are the standards you're going to apply. To talk about reusable, we think about the license for sharing, you think about provenance, and once again, documentation. So yes, it's a lot to think about, and that's pretty much why data management plans exist. They can be formal documents, sure, and for many they are like administrative chores, but they're also reflection tools because they help you think about the different things that are part of a project and things that you may usually forget. It's like going out on a trip. If you don't have a checklist of things you pack, chances are you may forget something behind. And while that can be something as simple as a toothbrush that you can just get another one when you reach your destination, if you forget your wallet, you may not end up going anywhere. So the same happens with data management. The idea is that on the one hand, writing a DMP means complying with funder or institutional mandates, but on the other hand, it's also about outlining all aspects of managing data in all phases of a project. It's about enhancing data fairness, increasing impact, making research more efficient. After all, we are forced to think about those issues in a more standardized, complete, comprehensive way. And then we have the idea that a DMP is a relevant tool to help make research easier to reproduce, and that is because you think about the whole process, the whole data management flow we discussed. We have to add also intentionality to all connected actions. So it's not our goal here to get into the details of a data management plan, even because we would need quite some time to do that, but let's just overview the most traditional sections seen in DMP templates. First, we have data collection and creation. Then we have data storage and security, documentation and metadata, data access, sharing, and reuse, and finally, data preservation and archiving. These are the 5 sessions that you usually see in most of the templates. And there are different templates because institutions, disciplines, and funding agencies can have some latitude about how they deal with data management. After all, practices across disciplines, institutions, or regions can differ in some aspects, and the DMPs tend to reflect those variations. Let's discuss then some example considerations we might include in a DMP. And one relevant consideration relates to costs. For instance, we think about how much it costs to collect the data. Let's suppose you want to learn about open science practices across different funders around the world. You could get a list of funders, find the websites, and search for information. You could scrape their websites. You could download their official documents and analyze them. Or you could design a survey and send it to agency representatives. You could try interviews that could be online or in person with quite different costs for each situation. For instance, I'm a team member of a project that has installed correspondence in 29 European countries and 10 others beyond Europe, from Brazil to Japan. These correspondents interviewed policy officers from a total of 55 funding agencies from all these countries, discussing open science and a broader set of responsible research and innovation practices. The interviews were then coded by an 8-person team, and the results are very rich, but also very costly. So writing a DMP can help you think about how you're going to collect your data, either based on the funding that you have available or the funding that you're planning to acquire. Then you have to consider how much it costs to document your data and then to store the data. Storage demands are entirely different for different types of data. For instance, video demands a lot of storage space, as you need over a gigabyte for an hour of HD video, and more than 10 times as much for 4K video. That costs money. And costs rise when you consider access and security. One thing is to buy a bunch of hard drives and keep them stored in different locations. Another is to put things in a repository where data may need to be protected, for instance, to safeguard intellectual property rights. We have discussed that already as a reason to keep data closed sometimes. So we have mentioned that for patent to be granted, its novelty aspect needs to be guaranteed by the fact that the information was not previously shared, right? So the cost for protecting research data needs to be taken into account in a DMP. But then there's also an alternative proposed by Cohen-Sasson and Tursinai earlier this year in one of the EMBO reports. In order to allow reproducibility without sacrificing IP rights, they proposed that scientific journals could intermediate the sharing of otherwise protected data from authors to replicators by establishing non-disclosure agreements that would somewhat protect the authors. They called it conditional access agreement, something that could also be listed as part of a DMP as a condition to share data. In other cases, an additional cost around protecting data is anonymizing. When we discussed GDPR in a previous block, we talked about how it is not always possible to share all the data you would like to. So you need to consider the as open as possible, as close as necessary approach. And there are multiple ways data could be anonymized. For example, researchers can use replacement and categorization. So names can be replaced by aliases or anonymous identifiers, and data that could help identify individuals can be converted into categories. So, for instance, if your data set includes the birth date of subjects, you can replace that with birth year, age group, how far you go depends, for example, on the number of records or the level of detail that you have in the database. Another possibility is to anonymize by aggregation or algorithm. So researchers can either output only aggregated results to a level that's acceptable by regulations, or an algorithm can be used. And this is very common within data science, where you're pretty much create a fake data set from the original one. But that fake data give all the statistical results that you could have from the original data set. That's an alternative that allows sharing of data for reproduction without having to open data that you couldn't open otherwise. And finally, it's important to mention that anonymization is the only effective solution to comply with data protection and openness when you're talking about microdata. And just to finish with the potential costs that can be considered while writing a DMP, there are those also associated with making data available and allowing reuse, and there's also preservation, something that we dig a little bit more into. When you think about costs related to data preservation, one of the considerations relates to whether you need short or long-term archive. That means while you could budget for lifetime storage, sometimes that should not be the case, and you must consider, for instance, is the data unique? Is it expensive to reproduce? Are you obligated to preserve the data? For how long? Usually mandates around 10 years, but what about longer term? The point is, not all data needs to be preserved, but researchers need to reflect on that while building a DMP, probably discussing options with their institution's data stewards and reporting those decisions in their plans. Then, about writing our own plans. So, guidance is extensively available within institutions and funders to help researchers find their way. And that will always manifest in the provision, for example, of DMP templates or by the recommendation of one of the numerous web-based tools available. The smart move is to always check what the university or funder advises to use. NWO, for example, suggests using DMP Online, which includes custom-made templates for researchers at different universities, also complying with a variety of regulations from other funders. And the templates even come with example answers and guidance. A similar tool is recommended by the Research Council Norway, which is the Easy DMP. And these slides and the links to the different tools are available in the Open Science Knowledge platform, which you access to open-science.cwts.nl. But institutional support usually goes way beyond the template offer. Universities and their libraries tend to offer courses, workshops, hands-on instructions to write a DMP, not to mention the support of data stewards that are becoming more and more common actors within the research environment. Funder-promoted workshops also tend to be available. For instance, a recent Nature article mentions the Dutch ZOMMV that has been promoting a series of workshops around data management with an estimated cost of around 40,000 euros per workshop. And this is considering the attendees' time as well. For me, that was quite a relevant example illustrating funders' commitment to data management. Additionally, we should highlight that DMPs are living documents. They should be dynamic and not something that's set in stone. Something that, because you wrote it, you're committed to it and your research is stuck and nothing can be changed. No, we can version DMPs. We can make adjustments as necessary. And to close our discussion around data management plans, let's talk about something we consider to be the future, the machine actionable DMPs. And for that, let's bring back the argument that a DMP is a chore, a formality. And yes, a DMP can be seen as a reflection tool that can help researchers think about the work, help design better research. But the fact is, more often than not, once a DMP is produced and deposited somewhere, it may never see the light of day again. We know, for instance, that funders will need more human resources to go through all DMPs, analyze them, monitor whether or not they're being followed, or maybe design policies or improve grants as a consequence of what they see. That would be very nice, but it's unreal in today's state of things. But the machine actionable DMPs can be a way to make these types of documents more valuable. Here's a nice illustration from a paper by Mixa and colleagues that represent that. What we see is that machine actionable DMPs could be stored by a specialized service that could issue DOIs to the data, that could recommend repositories, licenses, estimate costs, all in an automatic or semi-automatic way. Researchers can explore other DMPs, finding similar projects and related data. They can see how others are treating their data. And the funders, well, the funders could get automated information from the service, such as the user data, the project data, to link with awarded grants. Then they can get the DOIs of the deposited data and much more that could be used in an automated way to help monitor compliance, to better plan future grants, to help stakeholders make decisions. Well, with that exciting and promising development, we conclude our block on data management plans, and we follow with Ludo Waltman discussing open code and software.